All right, we're looking at lesson 3 today, and for us in our table of contents, that's going to be on page 13. And it is making scaled copies. So right now we know how to figure out if it is scaled. Now we're going to figure out how to make one. And we're going to start off, not with notes today, but a foldable, which I'm excited because I miss doing foldables. So just so everyone can see before I pass it out, it is double-sided, okay? So the way that we're gonna do that is if you, let's see, it might overlap just a tad, but it should work out fine. If you fold on the dotted lines, and then if you trim off the white side, y'all can see through. See how this side's a little bit longer on the other side? If you just trim off a little bit of this white, just make sure you're not cutting anything off. It won't overlap, but you can also leave it if it doesn't bother you. Either way is fine. So we're gonna do the foldable first, and then we'll look at the summary, and then get into some practice problems. Okay, can you go ahead and pass off the summary just so it's out? Guys, the summary I have on 2 different colors. They're the same thing though. It's just whatever paper I grab. Don't put the summary in yet. We're going to do the foldable first. Don't paper glue the foldable in yet, just because I want to show you how we're putting it in. All right, so to start off, this foldable pretty much is confirming or going back over everything we've done so far in Unit 1. So this is a really, really good review type of foldable. And again, you don't have to cut it, but totally up to you. All right. So let's look at this. I want to see what you guys can remember before I fill it out. All right, about 30 more seconds. Just get ready. All right, a scale tells how the measurements in a scale drawing or model represent the what? The blank measurements of the object. So the scale tells us how the measurements in the scale drawing or model represent the what? So think about the original. The measurements in the original are the what? Actual measurements of the object. So the original, think of those as the actual measurements. So it may tell us something like this: a scale 1 inch represents 3 inches. Because think of model airplanes. If we bought a model airplane kit, are those pieces going to be as big as a regular airplane? No. So it might say that 1 inch on the airplane model might equal 6 feet in real life, or something like that. It'll be a scale model. Okay, that's what we're looking at, trying to figure out how big or small it is, and then that magic number that we multiply all the sides by. Okay, that's where we're getting into the scale factor. So here on the other side, it says a scaled copy is a copy of another figure where each length was what? Blank by the same number. What did we do? Brio, multiplied. Each side was multiplied by the same number. So let's look at that example. Did she get you in?
She said it might take me back.
Okay. Hold on to that, and then we'll get you in tomorrow when we work on it.
Okay,
Thanks,
you.
babe. You're welcome. All right. So let's look at this model. If this was our original and it came to be this, if we know the bottom was 1 inch and now it's 3 inches, what was the change? How did they get from the first to the second one? Soraya? They multiplied by 3. So if this is by 3, how am I going to find this side? Times what by 3? The other side, right? All right, so we're going to do 1.5 times 3. So we've got 4.5. So 4.5 is going to be our new side. So what was the scale factor? The scale factor is the number that we multiply by. 3. Easy enough, right?
Yes.
All right. Corresponding parts are the parts of a polygon that are in the same what? Spot or position, yes. In any different two-dimensional shapes. The number each length of a polygon is what? To create a scaled copy. So each length is, again, what do we do? Multiplied. All right, so we're going to make sure we understand what corresponding is, so we are all in the same spot. All right. If I have this side right here, the corresponding side is this right here. It has to be in the same spot. We just wrote it, guys. Same spot. So this side is gonna match this side. This side is gonna match this side. What do we know about the different things that could match? What did we write down yesterday? It was 4 things it listed. What could match? Sides, Mario? Lengths. There's 2 others. One started with a P and one started with an A. Angles is one. Scarlett, remember the other one? You're gonna say angles? There's one more. Abby? Points. Good job. All right. So this angle is gonna match this angle. This angle is gonna match this angle. And this angle is gonna match this angle. And then I'm just gonna make one example of a point. So this point is gonna match this point. Any questions on how we did any of those corresponding? All right, so the scale tells us the actual size, right? Because we can't make the actual size. We would not have the room to build an airplane that big. The scale is going to tell us how big it actually is. The scale factor is the magic number that we use to make it larger or smaller. And we use that same number to multiply each of the sides, right? Okay, corresponding. That means it's the point, angle, side, length that is in the same what? We just wrote it. It's got to be in the same spot. Yes. Your test is next Thursday. I really need you guys to really be looking at this at night. Okay? All right. So what I need you to do is just close that up, and then you can either glue all of the back or just tape the top and the bottom. And we're not putting anything under it, so you're going to tape it all the way down. That way it ain't going nowhere. And then before we put the summary in, I want us to look at it real quick. Yours might be pink, it might be green, they're the same paper. All right, so our summary, basically what it is saying is to get from the original to the, and you don't have to color this one, I'm just showing you, to get to the original, from the original to the larger one, because we're going, the original is always first, how did they get from 1 to 4? Because I have to look at the same side to determine that. Ramon?
Multiplied by 4.
Multiplied by 4. So what is 2 times 4? And does that match? Yep. And then I'm just going to go ahead and tell you 2.24 times 4 is 8.96. So what is the scale factor going to be? Good. Scale factor is that magic number that we use to get it to the new one. All right, go ahead and put that in so it flips up. You guys are doing amazing today. You didn't get one. Nope, that goes right on top of the foldable so that it flips up. Y'all see mine? So it flips up. Nope, so it flips up. All right, we're gonna do a few lesson questions together, and then you guys are gonna do table questions. And it's not many at all today. White makes me sleepy sometimes. I like bright colors. All right, so we are looking at this paper. All right, our top question, as Ramon scares me half to death. All right. All right, so looking at this, it says number 1. These are our originals. These up here at the top. It says, draw a scaled copy of either figure A or B using a scale factor of 3. All right, so I will go with A just because I think that might be a little bit easier for us right now. If we're using scale factor of 3, each side has to be multiplied by 3. All right, so I'm going to figure out first what my original is. The top is 2. Not sure why I wrote 4. 2. Then we have 3. Then we have 3. And then we know that other one is a slant. All right, so I'm multiplying each side by our scale factor of 3. So what is my tall side going to be? 3 times 3. 9. All right, so we're going down. Make sure, since the bottom is going to be 9 also, make sure that you have enough on the bottom. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we're going up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so what is our top gonna be? 6, because 2 times 3. So we got 1, 2, 3, 4, 5, 6. And then what do we know we're gonna do with those 2 ends? They're gonna go together, right? And if it's not perfect, it is totally okay. So there is our new scaled copy. So now our new one is going to be 6, 9, and 9. So the new one is how many times bigger than the original? What was our scale number? 3. It's 3 times bigger because we multiplied by 3. So it enlarged 3 times. All right, number 2, draw a scale copy of either C or D. Which one do we want to do, C or D? C? Okay. All right, so let's figure this one out. So we've got 2, 1, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Let me see what it says. I don't know why, but it didn't print what it's supposed to be, right? 1/2. Some things it's not been printing lately, like our table the other day, and then the equations yesterday. I'm not sure if it's just like a formatting problem. It's okay, we'll write it in. All right, so they want us to do a scale factor of 1/2. So does that mean our new one is going to be smaller or bigger than the original? Smaller. Half as small. All right, so we are going to figure out what each of those is, what half of it is. So what do I know about 7? If I need half of that, what is that going to be, Brielle?
It's an odd number, so it's going to be 3.5.
It's an odd number, so it's going to have that 0.5 on the end, and it's going to be 3. All right, so we know this is going to be smaller, so I'm just going to start kind of in the middle because we'll have plenty of room. So I'm going to go 1, 2, 3, and I'm going to put the half on the top just because I like the bottom to be on a flat line. So I did 3, and then I went back to the very top and added half a line, half a box. All right, our bottom was 6. What's our half going to be? 3. 1, 2, 3. All right, our next right side was 5. Evie. Good job. It's an odd number, so it's going to be 2.5. So we got 1, 2, and then halfway. All right, the next one, it was 1, so it's going to be it's 1, so just half of that. So half. So we're going to go over only halfway. Yep, this is a small one. All right, so going down was 2, so we know that that's going to be 1. So since it's halfway in a box, one whole jump is going to be in the next halfway. So it's going to go, because halfway equals a whole, right? Which it's going to equal 1. All right, going across was 3 up top, so it's going to be what down at the bottom? All right, 1.5. So I'm going to go over one line, so there's our half, and then I'm going to go all the way. So there's our 1.5. And then going up was 1, 2, 3, 4. So going up, we're going to go up how many? 2. So we're at 1, 2. And then we know since that top was 2, it's going to be 1. So we just connect it. And I'm not going to make you put all those numbers. I'm just going to put the outside. So we got 1, 3.5, 3, 2.25, and then 1/2. So that one reduced in itself in half. right, we good on that one? All right, go ahead and fold that like we've been doing. I'm gonna look at 3.3 real quick. All right, it says Diego and Jada want to scale this polygon so that the side that corresponds to 15 units in the original is 5 units in the scaled copy. Okay, so they want the 15, so that is this right here. They want that side to be 5. All right, so then it says Diego and Jada each use a different operation to find the new lengths. Here are their finished drawings. So if we're going from, 15 to 5, what is our scale factor going to be? 3, okay? So we're dividing it by 3. So if we divide by 3, I'm going to write the new ones next to it. What is 36 divided by 3? 12. 30 divided by 3? 10. 21 divided by 3? 7. 12 divided by 3? 4. 5 divided by 3? Or 15 divided by 3? 5. 18 divided by 3? All right, so let's look at their drawings. It says, what operation do you think Diego used to calculate the lengths for his drawing?
He didn't use spring.
So what do we think he did? Mario. He subtracted by 10. Okay, so that's what he could have done. So what operations? So he subtracted by 10. It didn't print, but number 2 said, what did Jada do? What did Jada do? Danae? She divided by 3, or she multiplied by what? What's the reciprocal of 3? Remember, a whole number is over an invisible 1, right? So it looks like a fraction. When I flip that, what is the whole number as a fraction? 1/3. Good. So she divided by 3 or multiplied by 1/3. Bless you. So if they did, this is just my question, you don't have to write this down. If they asked us to do 15 to 5, would his even work? Is there a way to get a 36 to a 12 any other way than using the scale factor of 1/3? No. Look at his drawing. The way his measurements were, it doesn't even what? Close. It doesn't connect. So his is already not going to work. Okay? All right. Make sure that's folded. Put that on page 14. And then, let me see. We're going to do the next part a little backwards. I'm going to give you your cool down. Once your cool down is in the box, then I'm going to give you the practice problems. I know that sounds a little backwards, but I want the cool down so I can put that in the grade book for you guys. But you will see the cool down literally will take you maybe 10 seconds. So that's why I want to make sure that you get that done first.
If we finish the practice, can we go to the
Yeah, you're gonna do your cool down and then you're gonna do your practice problems.
And then can we work on the other ones that we did?
Yes. Alright guys, cool down and then I'm gonna give you the practice problems. So cool down first. Remember, I need to know what you know, not your neighbor.
What do you mean they did a code?
Okay, guys, listen. Your cool down. Listen. It says triangle Z is a scaled copy of M. So you're going to tell me which of those would work as that other triangle.
I did that.
So if it's a scaled copy, which ones would you be able to turn those numbers into? You're done? Name, box. When you're done, name and in the box. So for example, if everything was doubled, would that work as a scaled copy? Yes. If everything was cut in half, would that work as a scaled copy?
Yes.
Yes. So you're looking at which ones could they turn it into? So when you're done with that, go ahead and start your practice problems because we still got about 15 minutes. I just didn't want anyone to run out of time.
Is 5 minutes in there still recording?
Hmm?